The alternating series test. An alternating series is a series in which the sign of each term alternates from positive to negative or from negative to positive. Below are some examples of alternating series. The first example, the series from 0 to infinity of negative 1 to the n times 1 divided by the quantity n plus 1 cubed, is the series 1 minus 1/8 plus 1/27 minus 1/64, and so on. Notice how the signs alternate from positive to negative. In the second series, the sum from 1 to infinity of negative 1 to the n times n factorial over 10n, we have negative 1/10 plus 2 over 20 minus 6 over 30, and so on, and these terms alternate between negative and positive. An alternating series will converge under the following conditions. First, the a sub n's must be decreasing, and by the a sub n's we mean the a sub n's without the signs attached to them. It's like we're looking at the absolute value of the a sub n's. They need to be decreasing, and then their limit needs to be 0. If that's the case, then an alternating series will converge. If the limit of the a sub n's is not 0, or if the a sub n's are not decreasing, then an alternating series diverges. Example 1. We'll use the alternating series test to determine whether the following series converges or diverges. Because we see that it's alternating, we'll check the conditions for convergence for the alternating series test. So we'll first check to see whether or not 4 divided by n squared is a decreasing sequence from 1 to infinity. Using the calculator, we'll just simply graph the function 4 divided by x squared from 1 to infinity. We see that it is indeed decreasing. Now we need to check to see if the limit of 4 over n squared is 0. Well, evaluating that limit, we find that the limit as n goes to infinity, 4 divided by n squared, does in fact go to 0. So we know that 4 over n squared is a decreasing sequence, and its limit is 0, so we can conclude that the alternating series converges. Example 2, I'm again asked to determine convergence or divergence for an alternating series. I'll check the conditions for the alternating series test. I first check to see if 3n divided by 4n minus 1 is decreasing from 1 to infinity. Using the calculator to graph 3x divided by 4x minus 1, I see that it is indeed decreasing. And now I check to see if the limit is 0. Well, using L'Hopital's rule, I find that the limit as n approaches infinity of 3n divided by 4n minus 1 is 3/4. Although the terms of the sequence are decreasing, their limit is not 0, therefore we conclude that the alternating series diverges.